and welcome to Here Tutoring. In this video, we're going to talk about when and how to use the answer choices for the ACT math test. First, let's just make sure we say that we are allowed to use the answer choices. The ACT beginning and work to the end, showing all of our work. In fact, we shouldn't do that because our goal isn't to show anyone that we know how to do the question. Rather, our goal for the ACT math test is simply to get the right answer as quickly as possible, using whatever method necessary. And sometimes, the best method to get the right answer is to just use the answer choices and plug them back into the question, even if we know how to do the questions the right way. This is because sometimes the right way to do the question will actually take a lot longer than just using the answer choice. Now, let's talk about how and when to use the answer choices. Regarding the how, the most efficient way to use the answer choices is to start with C, since it will always be the choice that's right in the middle. If C ends up being too big, then we know the answer needs to be either A or B. Then we just need to pick either A or B to plug in. If it's wrong, then we know the answer is the other one. Likewise, if C ends up being too small, then we know the answer will be either D or E, so we pick one of them to plug in. If it's right, great. If it's wrong, then we know the answer is the other one. On the other hand, if we just started with choice A and worked forwards, we might need to try 4 different choices if the answer is E, instead of just 2 using this method where we start with C. Now, if 2n plus 1 squared minus n minus 5 squared equals 16, then what could be a value of n? Our choices are 1, 2, 4, 5, and 6. For this question, we should recognize that it would take quite a while to FOIL out the entire problem and find the roots, so this would be a perfect question to use the answer choices for. So let's start by trying choice C, which is 4. When we plug 4 in, we end up getting 9 squared minus negative 1 squared equals 16, which simplifies to 81 minus 1 equals 16, which is 80 equals 16, which doesn't work. We see that 80 is too big, so let's try one of the smaller choices. Let's try A by plugging 1 back into the original equation. When we do this, we end up getting 3 squared minus negative 4 squared equals 16, which simplifies to 9 minus 16 equals 16, which simplifies to negative 7 equals 16, which doesn't work either. So now we know the answer needs to be between A and C, or between 1 and 4, so we can just pick B at this point and move on. But if we wanted to check this, we would see that plugging 2 back into the equation gets us 5 squared minus negative 3 squared equals 16, which simplifies to 25 minus 9 equals 16, which simplifies to 16 equals 16. With this method of using the answers, we will only need to try at most 2 of the answer choices, whereas if we started from the beginning, we might need to try up to 4 choices. Now, if we wanted to actually set this question up and solve it, we would have had to distribute or FOIL out everything, combine all the like terms, get everything to one side so they equal 0, and then find the roots, probably using the quadratic formula, which would have taken a lot longer. Using the answer choices was a much better option for this question. Now, let's try one more example together. Let's take a look at this question. In a bag of marbles, 1/3 of the marbles are red, 1/4 of the marbles are blue, 1/6 of the marbles are green, and 21 marbles are yellow. How many total marbles are in the bag? Our choices are 48, 60, 72, 84, and 96. Like with the last question, we can figure out pretty quickly that this question will take a while to set up and solve, and that using the answer choices will probably be quicker and easier. So here's how we could use the answer choices. Let's start with C, which is 72. If there are 72 marbles in the bag, then 1/3 or 24 are red, 1/4 or 18 are blue, 1/6 or 12 are green, and 21 are yellow. This adds up to 75 marbles, which is higher than 72, so we know that 72 is too small, which means we should try D or E for our next answer choice to use. Let's try D, or 84. If there are 84 total marbles in the bag, then 1/3 or 28 are red, 1/4 or 21 are blue, 1/6 or 14 are green, and 21 are yellow. This adds up to 84, which is what we were aiming for, so our answer is D. As you can see, if we had started from A and moved forward, we would have needed to try 3 answer choices instead of just 2. If we had wanted to set up and solve an equation for this question, we would have done 1/3 x plus 1/4 x plus 1/6 x plus 21 equals x. Then we would have changed the fractions to common denominators to get 4 over 12x plus 3 over 12x plus 2 over 12x plus 21 equals x. Then we would have combined the like terms to get 9 over 12x plus 21 equals x, which simplifies to 3 over 4x plus 21 equals x. Then we subtract 3 over 4x from both sides to get 21 equals 1 over 4x. And finally, we multiply both sides by 4 to get x equals 84, which is our answer, but that took a lot longer than just using the answer choices. So, the two examples that we just went through help give us an idea of what kinds of questions would be good candidates for using the answer choices. Generally speaking, the questions that we want to consider using this method for are ones where setting up and solving the algebraic equation would take longer than just plugging in the answer choices. In the next video, we're going to talk about an ACT math strategy similar to this one, which is substituting in random, easy numbers into the question to figure out the answer. Thanks for watching, and I hope to see you soon.